Hi students, this part is on trigo functions and graphs in your A Math. Okay, so this is the first part of trigo that you will learn. I will break this into two parts. The first part is trigo functions, and then the second part is trigo graphs. Okay, firstly, in trigo functions, we talk about three more new trigo ratio. Okay, before that, your basic tuakaso cosine is equals to adjacent over hypotenuse in a right angle triangle. Sine equals to opposite over hypotenuse, and tangent equals to opposite over adjacent. Okay, now some schools will teach this in trigo 1, or some school will teach this in trigo 2, which is chapter 10. Okay, this is called secant. Okay, not sec, but secant. Secant is 1 over cosine theta. It's the reciprocal of cosine. So it is h over a. So how to remember this identity? S and C must be together. The S and the S cannot be together. So that is how I remember as a student. Okay. Cosecant is 1 over sine theta, which is equals to h over o. Okay, and cotangent is the reciprocal of tangent theta, that is a over o. So in cosecant, the C and the S have to be together. Okay, then next is about the relationship between sine theta and sine 90 minus theta. Okay, important concept here, in a triangle, if I label this as A, B, and C for the sides, if this is theta, this is 90, you must know that this is called 90 minus theta. This concept will come back again in R formula, which is important. Alright, so in this triangle, there are two angles. One is theta, one is 90 minus theta. Okay, if I use sine theta, if I look at the theta which is blue, okay, I'm talking about A over C, opposite, because this is opposite to the blue angle, this is adjacent to the blue angle, and this is the hypotenuse. Okay, cosine theta is equals to B over C, and tangent theta is equals to opposite over adjacent, that's A over B, opposite over adjacent. Okay, now if I look at the 90 minus theta and I label this red, A would be adjacent to 90 minus theta. So you see, the side of the angle is relative to the side of the triangle is relative to the angle. Okay, and if I'm looking at B, it is far away from the angle 90 minus theta, so this guy is opposite to 90 minus theta. Okay, so in red, cosine of 90 minus theta is adjacent. The adjacent is now A. Hypotenuse is always still hypotenuse. Okay, sine is opposite B over hypotenuse, and tangent is opposite over adjacent for the red one, so B over A. Okay, then you can see that the relationship, these two, they are equals to each other, so this is equals to sine theta. There you have it. This is the relationship between 90 minus theta and theta. Okay, cosine of 90 minus theta is equals to sine theta. Sine of 90 minus theta is equals to cosine theta. Okay, and tangent of 90 minus theta is equals to 1 over tangent theta. Okay, so this is the relationship between cosine 90 minus theta and sine theta, sine 90 minus theta and cosine theta, and tangent 90 minus theta is 1 over tangent theta. Okay, now then there will be a very popular kind of question where they tell you, oh, cosine A is equals to 3 over 5. When they give you 3 over 5 like this means that the 3 is the adjacent side. Label here as your A. Okay, 3 is the adjacent, 5 is the hypotenuse. Then we do Pythagoras theorem, 5 square minus 3 square, because 5 is the hypotenuse, and that will be equals to 4. 4 is the opposite side. Sometimes your answer cannot be expressed nicely as a whole number, then we put it in surd form. Okay, so important is now I have all my 3 sides of the triangle, I can answer all the question. In A, I want sine A, and that would be equals to opposite of angle, so it's 4 over 5. Okay, B, cosecant A. Cosecant is 1 over sine A, so that's the reciprocal of sine A, and that will be 5 over 4. C, tangent A, that will be equals to opposite over adjacent, so 4 over 3. And D, cosine 90 minus A. Remember what's the identity of 90 minus A? Is equals to sine A, and you can immediately write down, because you already have it there, 4 over 5. And E, tangent of 90 minus A is equals to 1 over tangent A, and that will be equals to 3 over 4. We're taking the reciprocal of 4 over 3. Okay, so whenever they give you a trigo function equals to a fraction, always remember to draw a triangle. For now, this triangle is still basic. Later, we'll talk about triangles in different quadrants. This special angle table, okay, you have to know how to get the values in the special angle table. But before that, let's put everything in terms of radian. So there's 2 degrees of measure in this topic. One is called degree, one is called radian. Okay, when you see something like 1 degree, this is degree. But if you see something like 1, it doesn't have a degree there. It is understood to be 1 radian. So be careful, don't be tricked. Okay, if you cannot remember how to convert degree to radian, pi is equals to 180 degree. Regardless of whether you are doing in radian measure E-math or trigo in A-math, pi is equals to 180 degree. 90 degree is called pi over 2. 45 degree is called pi over 4 because I take pi over 2 divided by 2. 30 degree is called pi over 6, and 60 degree is called pi over 3. Okay, the next two, 270 and 360, you need to know so that when you draw your graph sketching, it is easier to draw the axis 3 pi over 2 as well as 2 pi. Okay, in this special angle table, okay, you are expected to leave the answer in exact form. In this case, exact form also means insert form if you cannot put it in a nice whole number. Actually, the 0 and 90 degree is not so important. Okay, so you can keep 0 and sine 0 into your calculator, you will get 0. Sine 90, you will get 1. Cosine 0, you will get 1. Cosine 90, you will get 0. These two, I will touch on it when we do trigographs. Okay, tangent 0 is also 0, whereas for this is undefined. Okay, now how do we get the values for 30, 45, 60? Okay, actually most of them you can use your calculator to work out the answers. Okay, for example, the first one, sine 30, all I need to do is to make sure my calculator shift setup number 2, change it to degree mode first. Okay, sine 30, okay, and that is equals to half. So I will just write half over here. Okay, of course the exam will not give you this table. The exam will ask you to express things in the form of, okay, 30, 45, 60. Okay, now when I key in sine 45, it will become an irrational number. What is an irrational number? It is a number that has non-stop and non-recurring decimals. Okay, 0.707 . So that's where I wrote it down here. When you key in sine 45, you get this value. Now I go and power 2 it in my calculator. Power 2. I know, I will get half. So what does it mean? This means that when I do sine 45 and I square it, is equals to half. So if I don't square it, when I do sine 45 is equals to square root of half. And that is 1 over square root 2, because square root 1 is 1. Okay, actually it's nicer to go and rationalize it. Multiply by root 2, multiply by root 2, you will get root 2 over 2. Okay, so sine 45, it will be called 1 over root 2, or sometimes, most of the time, you will use root 2 over 2. Okay, now sine 60 is also going to be irrational, so I key in sine 60 into my calculator, I key enter, I get 0.866, I square it, I will get 3 over 4. So sine 60 square equals to 3 over 4. So what is sine 60 equals to? There is square root 3 over 4, and 4 can be square rooted, so it's called root 3 over 2. Okay, now cosine 30. Okay, cosine 30 is actually equals to sine 60. So that is root 3 over 2. I will explain to you. Okay. Remember just now we learned that cosine theta is equals to sine 90 minus theta. Okay. It doesn't just mean this way. It also means that any value you put here, 30. Okay. And so that means theta is 30, right? 90 minus 30, that's 60. They are equals to sine 60. They are the same. Same for sine. If I put in sine 30 degree, it is the same as cosine 60 degree. Okay, so this is called the relationship of the supplementary angles. That means if two angles add up to 90, you can use the 90 minus theta relationship. So when we go back to here, cosine 45 is the same as sine 45. That is 1 over root 2 or root 2 over 2. Cosine 60 is the same as sine 30, and that is half. Okay. Next, I use the calculator. I key in tangent 30. I will get equals to, again, irrational number, so I square it. 1 over root 3. If I rationalize, it is called root 3 over 3. Okay. Tangent 45 is equals to 1, okay, and then tangent 60, again irrational number, so I go and square it, I'll get 3. So this is called square root 3, and these are the important values in your special angle table you need to know. Okay, how will they ask you? Before that, when you see sine square x, it means sine x the whole thing square. If you see cos square x, it means cos x the whole thing square. Okay? How will they ask you? Without using a calculator. Now, even though they say without using a calculator, the calculator is still with you. So you will be able to know that sine 30 just key into a calculator is half. Without using a calculator means they want the answer in insert form. That's all. Insert form. Okay, cosine 45, you key in cosine 45 and you do a square method, you should know that it's root 2 over 2. Tangent 60 is called square root 3. Okay, that's where you get half minus root 6 over 2. Remember your root 2 times root 3 is equals to root 6, and the final answer is 1 minus square root 6 over 2. Okay, what happens if it is in radian form and there's a square? You cannot key the whole thing into a calculator and get an answer. Okay, so whatever you do, right, you can only key the sine pi over 6. Remember to change this to radian into a calculator, then you can get a value. If it's irrational, then you convert it yourself. Okay, so you cannot just expect to key the whole thing into a calculator and get an answer, because the question, even though the question says without using calculator, it means to put it in insert form. For this is equals to half square. Okay, if you do a lot, and then you will know your values of the special angle very well. Okay, minus 3, this guy is root 3, and then there's a square down here. So this will be called 2 multiplied by 1/4 minus 3, root 3 square is 3, minus 9. The answer is negative 8.5. So when there's square, it just means that sine theta bracket the whole thing square. It has the same meaning. It's just the way mathematicians write. Next, we talk about basic angle. The two things you must know. What is called a basic angle? A basic angle is acute, means very cute. It's less than 90 degree. It's smaller than 90 degree, and you must make with the x-axis. Okay, every angle has a basic angle. Okay, if your angle is called 90 degree, first you must know how to draw where is 90 degree. This is called the 4 quadrants of trigo. This is 0, this is 90, this is 180, so this is 270, and this goes back to 360. Okay, a 45 degree will look like this. We will always count the trigo this way first. Okay, 45 degree. The basic angle of 45 degree is still 45 degree because it is an acute angle mixed with the x-axis. Okay, so in the first quadrant, it's important to know that your angle is the same as your basic angle. In the second quadrant, if you are drawing 135, 135 is greater than 90 and smaller than 180. So it is here, over here, 135 degree. Okay, where is the basic angle? The basic angle is here. It must be a less than 90 degree and mixed with the x-axis. Okay, and that is 45 degrees still. Okay, so the basic angle of 135 is 45 degrees. And you must know that in the second quadrant, to get your theta is you always 180 minus the basic angle. In the third quadrant, if you are 225 degree, same thing, the fourth quadrant, 225 is more than 180, so 180 is here, okay, but less than 270. The basic angle of this angle is over here, okay? So I know that the whole thing is 180, the whole thing is 225, this part is 180, so this will make me 45 degree as well. The basic angle is 45 degrees. And in the third quadrant, to get what is your theta is equals to 180 degrees plus the basic angle. Okay, in the fourth quadrant, you are doing more than 270 but less than 360, so it comes to here, 315 degree. The basic angle must go to the x-axis, 45 degrees as well. The basic angle is 45 degree, as well as the theta to get here is 360 minus the basic angle. Okay, now why is it so? So remember two things to get from here. One basic angle can help you find four big angles, okay, as well as every big angle or every angle has a basic angle. If you key into a calculator, you will realize that number one, so for example, I just take sine 45 is equals to 0.707. I key in sine 135, it is still equals to 0.707. I key in sine 225, it is still equals to 0.707 but with a negative. Later on, when you do four quadrants, then you will understand. Okay, if you key in sine 315, it is still negative 0.707. So the values are all the same except for the plus minus sign. That's why one basic angle can give you four angles. So if 65 is your basic angle, what are your four angles? The first one, first quadrant, in the first quadrant, so let's refer to the top. In the first quadrant, your theta equals to the basic angle. The second quadrant is equals to 180 minus 65, and that is equals to 115 degree. The third quadrant, theta is equals to 180 plus 65, and that is equals to 245 degree. And the fourth quadrant is 360 minus 65, and that is 295 degree. Okay, so these are how we find the four quadrant. Again, this kind of question will not come in the exam. It's just to know, for you to see whether you understand or not. Okay, next, 220 degree. Let's draw it out. More than 180 but less than 270. So here is 220 degree. Okay, we know that over here is 180 degrees, so which means that the basic angle here is 40 degree. So what are your four angles? The first angle is 40 degree. The second angle is 180 minus basic angle, that is 140 degree. The third angle is 180 plus 40 degree, and that will be 220 degree. And the fourth will be 360 minus 40 degree, and that will be 320 degree. So these are your four angles if you have one basic angles. The next part, we are going to do the same thing. It is just that it is in radian. Okay, let me teach you how to visualize in radian. Zero is here. 90 is called pi over 2. Here is pi. This is called 3 pi over 2. And you go one round, it is called 2 pi. Okay, so pi over 6 is in the first quadrant, is the 1/6 of a pi. So this is pi over 6. And the basic angle is still pi over 6. The first quadrant, still the same thing, theta is equals to basic angle. In the second quadrant, if my basic angle is equals to pi over 6, okay, if my basic angle is pi over 6, that means my main angle, now pi is like algebra, pi is 1, 1 minus 1 over 6. What you are going to left with here is 5 pi over 6. Also, this is how we visualize in terms of pi. So in the second quadrant, we don't use 180, we use pi minus basic angle. Okay, pi minus basic angle. Okay, what happens if it's in the third quadrant? In the third quadrant, you will go more than pi but less than 3 pi over 2. The basic angle over here is pi over 6. Then I have pi plus pi over 6. Pi is like 1 whole. 1 whole plus 1 over 6. That's 7 pi over 6. Over here, theta is equals to pi plus pi over 6. Okay, and in the fourth quadrant, the basic angle is over here, pi over 6. I know that one complete round is called 2 pi. Okay, so 2 pi is 2 whole. 2 whole is 12 over 6. 2 whole is the same as 12 pi over 6. 12 over 6 is 2. Minus 1 over 6. So in this case, the angle is called 11 pi over 6. And in the fourth quadrant, theta is going to be called 2 pi minus pi over 6. Okay? If the angle is pi over 7, I know that this is in the first quadrant. Pi over 7 is here. Okay, pi over 7 is right down here. So theta is equals to pi over 7. Second quadrant, theta is equals to pi minus pi over 7. Pi is 1 whole. Just use calculator. 1 whole minus 1 over 7. 6 pi over 7. Third quadrant is called pi plus pi over 7. That will be 1 whole plus 1 over 7. 8 pi over 7. And the last one is called 2 pi minus pi over 7. That is equal to 2 pi is 14 over 7 minus 1, 13 pi over 7. And these are all your 4 quadrants. Angles in the 4 different quadrants. 5 pi over 4. 5 over 4 is a little bit more than 4 over 4. So this is called 5 pi over 4. The basic angle of 5 pi over 4 is pi over 4. Okay, so in the first quadrant, it is called pi over 4. In the second quadrant, it is called pi minus pi over 4. And that is called 3 pi over 4. In the third quadrant, you already know because that was what is above. You have drawn here and it's in the third quadrant. The fourth quadrant is called 2 pi minus pi over 4. 2 whole is 8 over 4 minus 1, 7 pi over 4. And these are all the values in the 4 quadrants. Okay, what happens if I have negative angles? Just now, when I want to draw an angle, is always going in this way, anti-clockwise direction. So if I want to draw a negative angle, it just means that it starts from below. It goes this way. For example, this. You go to here, this is called negative 220 degrees. Okay, so it just means that it goes in the opposite direction. The basic angle, it is still the same. It is still the angle that makes with the x-axis. It is still the angle that makes with the x-axis. The basic angle is equals to 45 degrees. The basic angle for this guy is here. It is still equals to 45 degrees. The basic angle for this guy is here. It is still equals to 45 degrees. and the basic angle of this guy is here. It is still equals to 45 degrees. Okay, so next, what happens if you have angles that is over 360 degrees? Something like this, 400 degrees. Okay, then it just means it goes more than one round. This is 360. Yeah, it comes to here. So this is 400 degrees. And it exceeds one round. One round is 360. It exceeds by 40. So the basic angle is equals to 40 degrees. What happens if it is 1000 degree? Okay, still the same thing. One round 360. Two round 720. Okay, so two round is 720. I know that first round is 360. Second round is 720. I add again is 1080. Three round is 1080. But I want 1000. Means I will reach this quadrant. I need another 80 degree to form 1080. Okay, so this is why you can see that the basic angle is 80 degree. Okay, so for negative angle, it just means it comes from the opposite direction, the clockwise direction. And if you are over 360, you just go more rounds, okay, until you reach the angle that you want. C is in which quadrant? Then try to form the basic angle. Okay, the basic angle must be in the correct quadrant. Okay, and then now there are positive and negative parts where the angle is. This is called the four quadrants of trigo. In the first quadrant, from anything that is from 0 to 90, you sine that angle, it will be positive. You cosine that angle, it will always be positive. You tangent that angle, it will still be positive. Okay? But if you go to the second quadrant, in the S quadrant, anything that is from 90 to 180 degrees, if you sine that angle, it will be positive. If you cosine that angle, it will be negative. If you tangent that angle, it will also be negative. Okay, so this one is from 0 to 90 degree, and then this one is from 90 to 180 degree. Same thing if you are at this quadrant, if you have any angle that is between 180 to 270 degree, you sine that angle is going to give you negative value. If you cosine that angle, is also equals to give you negative value. If you tangent that angle, is going to give you positive value. Okay, and lastly, for any angles that is from 270 to 360 degree, okay, if you sine that angle, is going to be negative. If you cosine that angle, is going to be positive. And you tangent that angle, is going to be negative. Okay, and so this is how we know that the angles are called ASTC. A means all are positive. S means only sine is positive. So when sine is positive, right, you must think binary. If sine is positive, means cosine negative, means tangent negative. If tangent is positive, it means tangent is positive, sine negative, cosine negative. The opposite is true. If you have in the C quadrant, cosine is positive, sine is negative, tangent is also negative. Okay, and that is how we know the ASTC quadrant. How to remember? ASTC must start from here, then goes all the way to here. Okay, all science teachers are crazy. Okay, so that is how we remember the ASTC quadrant. How do we use ASTC to solve questions? Okay, first and foremost, okay, come to here. There are three very important steps. Number one, find the basic angle of each big angle that you are given. Identify which quadrant is it in. Then you do ASTC to see whether is it positive or negative. Okay, let's write at the top. First quadrant is A, second quadrant is S, third quadrant is T, fourth quadrant is C. Okay, number one, 120, the basic angle of 120. Let's draw 120. 120 is bigger than 90 but smaller than 180. It is here. So the basic angle is equals to 60 degree. I write down over here 60 degree first. Okay, in this quadrant, it is called the S quadrant. It means cosine must give you a negative value. Hence, I put a negative in front and then cosine 60. What am I doing? I'm using the basic angle to help me find the answer. Because remember your special angle table, you only have 30, 45 and 60 degrees. Okay, you cannot have anything that is different from the three values. Then in this case, you see for sure the basic angle will be in the special angle table. Okay, cosine 60 and that is negative half. Again, we go to 210. Let's draw the angle. 210 is over here. For a start, let's all draw the angle. You visualize can, but if you screw up, you will careless and you will lose marks. Okay, 210 is in the third quadrant. The basic angle should be here. 210 minus 180, 30. You realize that 30 again, special angle table. Okay, firstly, 210 we identify that is equals to 30 degree because that's the basic angle of 210. Now in this quadrant, this is called the T quadrant. Tangent is positive. I don't need to write anything in front. So tangent 30. And if you know your special angle table well, you know that this is called root 3 over 3. If not, just use your calculator, key in tangent 30, you get this value and you square it, is 1 over root 3, rationalize is root 3 over 3. Okay, the next one, what happens if it's in radians? Same thing, 7 pi over 4 is very close to 8 pi over 4. So this is 7 pi over 4 because it's very close to 8 pi over 4. 8 pi over 4 equals to 2 pi. 7 pi over 4 is very close to 8 pi over 4. So that's why it's in the fourth quadrant. The basic angle is pi over 4. Again, I identified the basic angle, so this is pi over 4 first. In this quadrant, it's called the C quadrant. So you have to write a negative cosine over here. Okay, sorry, negative sine pi. Okay, pi over 4. Pi over 4 is 45 degree in your special angle table. Don't key in the negative inside. Okay, you may key in like this. Sine, okay, pi over 4 is 45. So you key in 45 into a calculator. 0.707. You square it. Is equals to half. So before you square it, it's called negative 1 over root 2. You rationalize it. It's called negative root 2 over 2. Just multiply by root 2, multiply by root 2. Okay, you get your answers. Okay, next come a harder type of question. Okay, if cosine 220 is equals to negative p, okay, negative p means is negative p over 1. This concept very important. Negative p over 1, and okay, I go to 220, so this is 220 over here. Okay, 220 p, this is adjacent, 1 is hypotenuse. Okay, 90 degree. The basic angle is 40 degree. Okay, the hypotenuse is 1, the adjacent is called negative p, but in this case, okay, we just put the p is fine first. Okay, it's fine. Alright, this guy use Pythagoras theorem, 1 square minus p square, and that is square root of 1 minus p square. Okay, so now I have all my three sides. Don't need to worry about the negative sign. For those that has the degree one, you don't have to worry about the negative sign. First, cosine 40 degree. So you look here, 40 is already here, and that will be equals to cosine adjacent over hypotenuse, that is p over 1, that is still equals to p. Okay, tangent 140 degree. The basic angle of 140 degree, if you cannot visualize, is here. This is 140, the basic angle is 40, so this is equals to 40 degree. Now in the second quadrant, this is called the S quadrant. Tangent must give you a negative value, so it's negative tangent 40. Okay, the negative put on the outside, tangent 40 is opposite over adjacent, because 40 is here, we are using 40 to get the answer. Square root 1 minus p square over p, and that's all. Okay, and then in part 3, sine negative 320 degree. Okay, so I go opposite direction to the fourth quadrant. This is negative 320 degree up to here. The basic angle of 320 degree is also 40 degree. In this case, it's called the A quadrant. So everybody is positive. Sine 40 degrees, and that will be opposite square root 1 minus p square over hypotenuse, and that is square root 1 minus p square. Okay, so for angles, you don't have to care about the negative first. They give you the negative is just because it is in the quadrant of it. Okay, in the quadrant of it. Okay, again, sine 130 degrees is equals to k. I will draw the angle 130 over here. Okay, where is the basic angle? The basic angle is 50 degrees, and I draw this downwards. This is my triangle. K is called k over 1, opposite is k, here is 1, this is called square root 1 minus k square. Okay, so number 1, sine 50 degree, that's in the first quadrant, opposite over hypotenuse, so that it gives you the same answer. Part 2, cosine 40 degree. How is 40 degree related to 50 degree? Remember the complementary angle, they add up to 190, right? So this is equals to sine 50 degree, because 40 and 50 add up to 90, and that answer is still equals to k. Okay, in the next one, tangent 230 degrees. So 230 degree is going to be in the fourth quadrant. Here 230 minus away 180, you will get 50 degree. Okay, so this is equals to tangent 50, because over here is in the T quadrant. Tangent, look at the red triangle, opposite over adjacent, square root 1 minus k square. For square root with an unknown inside, you don't have to leave it in third form. Okay, and then part 4, for sine negative 220 degree, it is going to be in the opposite direction to this quadrant here. That is the second quadrant. Negative 220, the negative just means it's opposite direction. You don't really have to care about the negative. Okay, so we know that the basic angle here, 220, take away 180, left with 40. The basic angle here is 40, equals to sine 40. But in your original triangle over here, do you have 40? No, you have 50. So this is called the complementary angle, cosine 50 degree equals to square root 1 minus k square, adjacent over hypotenuse. Okay, and then now I'm going to talk to you about a very common type of question where they tell you that angles A and B are in the same quadrant such that tangent is equals to 5 over 12. Take note of whether is it positive or negative. So this is positive, and cosine is negative. So when tangent is positive and cosine is negative, there's only one possibility, and that is in the third quadrant. Okay, so the third quadrant, the A will look like this. Remember, it must always goes to here. This whole thing is called the A. Remember, like what we did just now, then we know that this is called the basic angle. Okay, when the angle is an unknown, yes, you have to put the positive and the negative values. Okay, what do I mean by that? Tangent A is opposite, this is opposite, this is adjacent. So look at the triangle, opposite is here, 5. Adjacent is here, 12. But because this is 0, this is the axis, this should be negative 12 and negative 5. Okay, and then you do a Pythagoras theorem, you will be able to get 13 over here. Okay, it's important to label the negative for this type of question where they give you tangent A, tangent B kind. Next, I draw for B. It is also in the third quadrant. It comes to here. This whole thing is B, 90 degree, 90 degree. The basic angle is right here. Okay. Now, cosine B is equals to negative 1 over square root 3. This is my adjacent. This is my hypotenuse. The hypotenuse is always positive. The adjacent is negative 1. Okay, then for this guy, square root of root 3 square plus, minus 1 square, because that's the hypotenuse, minus 1 square. Okay, and that will be square root 2. And square root 2, because it is under the axis, you must put a negative in front of the square root 2. Then with this, we can answer all the question. Okay, let's look at A only. Sine A is equals to opposite over hypotenuse. So you take opposite, negative 5 over 13, just like that. So look at the opposite, look at the hypotenuse, just plug in. So that's why the negative is very important. Okay, so that's why the negative is very important. Of course, there are other ways you can do without the negative, but you must own self see that I am in this quadrant. I need to know that I am positive or negative. Okay, B, cosine A is equals to adjacent over hypotenuse, negative 12 over 13. C, sine B is equals to, so sine of B is here, the opposite is this length, negative root 2 over root 3. Okay, rationalize, that will be negative root 6 over 3. Multiply by root 3 to both the numerator and the denominator. D, tangent of negative B. This one super important. Okay, so we know that B is in the third quadrant. So look here. This is B. So negative B means you must go in the opposite direction. Here, you are in the second quadrant. Okay, you are in the second quadrant. This is called the S quadrant. The answer must be a negative value. The answer must be the negative value. So where is my tangent B? Okay, I look at this diagram here. Tangent B, root 2 over 1. There's a negative and negative. That's why it became positive. Okay, but you can only to write these two because you know that negative B is in the second quadrant. Just put a negative sign in front of all the positive values because you must know that in that quadrant tangent is going to give you a negative value. Okay, so that's the important thing about trigo. Okay, that's the important thing about trigo. Okay, next one, E, sine pi over 2 minus A. Pi over 2 is 90 degrees. Sine 90 minus A, that's equals to cosine A. Okay, that's equals to cosine A. And cosine A, I think we already have it in front, negative 12 over 13. Okay, and lastly F. Okay, cotangent B is equals to 1 over of tangent B. I believe we already have tangent B. Okay, so that's 1 over square root 2. Okay, this one, sorry, there should be a negative down here. Rationalize is called root 2 over 2. Okay, and this is how you do basic angles in about 45 minutes.